It'll expanding faster than the fabric of space-time can keep up with it. And it'll just rip. And I'm terrified by this.
The star Betelgeuse, not to be confused with the character from the movie, is indeed a colossal celestial body. If we were to swap Betelgeuse with the Sun, it would extend past the orbit of Mars and even reach the asteroid belt. And what's even more terrifying is that the James Webb Telescope has made a concerning new discovery about the Betelgeuse supernova. And Neil deGrasse Tyson has a few words on the topic. Despite its proximity of 700 light-years to us, Betelgeuse is the closest star to our solar system, which scientists anticipate will ultimately end its life in a supernova explosion. Renowned astrophysicist Neil deGrasse Tyson has been vocal about Betelgeuse, noting its remarkable size and its stunning red-orange hue that makes it one of the most noticeable stars in the night sky.
Like any star, it will run out of fuel in its core, and it starts changing. It starts bloating and getting so large that it will engulf the orbit of Mercury and Venus and come very close to Earth. So imagine looking on the horizon and sunrise is half the sky.
The Betelgeuse star is possibly at the tail end of its lifespan and is most likely breathing its last. The red supergiant star will likely explode in a massive supernova, spewing radioactive debris around it. The Betelgeuse has fascinated astronomers since the Middle Ages. Today, we know that this exceptional phenomenon is a star in the middle phase of its life. Betelgeuse is undoubtedly one of the brightest stars in the night sky. Its luminance allows it to be easily noticeable, even by amateur astronomers. The big red giant has been the muse of many poets and scientists alike. In many religions, the star holds a compelling position. Its brightness and radiant glow amongst the Orion constellation made many equate it to heroic mystical figures around the globe. Betelgeuse is the primary star in the Orion constellation. It usually shines with an average brightness of 0.5 magnitudes and weighs almost 20 solar masses. Betelgeuse only started appearing so prominent in the night sky since it inflated into its red supergiant phase. Betelgeuse's brightness increased by about 50% due to its decay process. Before this transformation, in its earlier phases, scientists have reason to believe that it was not as conspicuous in the night sky. Humans have only just known Betelgeuse in this dimension. Betelgeuse's evolution has been going on for millions of years. It is believed that the star was once much smaller than it is today. Betelgeuse swallowed its entire planetary system during its metamorphosis. If we put the star in our solar system, Betelgeuse would be large enough to take up space from the center to Jupiter easily. If the star were to explode right now, Earth would be treated to one of the most magnificent views that can grace the night sky for a few seconds. Astrophysicist Neil deGrasse Tyson has now commented on this impending disaster. Some scientists have had reason to believe that that has already happened, and we will explain their reason for this assumption as we go. For astronomers, the end of a star is a unique event. The explosion of a supergiant with such proximity to Earth can be quite frightening. Researchers, however, are excited that Betelgeuse, with its distance of merely 650 light-years, is close enough for us to witness the amazing spectacle. It can be likened to seeing a movie in 3D. After the giant red star sends its last rays of light into the cosmos, the star would collapse in a massive implosion. The implosion would be triggered when the fuel reserves of the star have fallen below a critical amount. Here on Earth, we can almost intimately experience this fascinating celestial phenomenon. The first recorded supernova explosions visible from Earth in our galaxy occurred between 1006 AD and 1054 AD. Many people witnessed the event. The lack of artificial lights coloring their skies made it easy for many people to catch the impromptu light show. Records of the phenomenon can be found in ancient Chinese, Japanese, and Arabic writings. People saw a bright light in the sky that continued to shine for weeks or months. In 1987, a supernova exploded in our neighboring galaxy. Despite the massive distance of 170,000 light-years, the collapsed star flared up brightly. The supernova's glow was so massive that we could witness it for a few seconds here on Earth. The star that collapsed was dubbed Sanduleak, 69,202A. Sanduleak was a blue supergiant with about 17 solar masses. Its explosion was the last supernova visible from Earth with the naked eye. With advanced telescopes, researchers can witness these celestial incidents in much more distant locations. Nonetheless, star explosions are rare cosmic events and are hardly ever explored. Only a few scientists dedicate their precious time to chasing down supernova explosions. As Betelgeuse gears up for its final moments, the star becomes brighter and brighter as the energy inside the star becomes more intense. From Earth, we would then be able to recognize every night that the star's brightness and extent are dramatically increasing. The photosphere is the star's outer shell from which light is radiated. The researchers also noted that the photosphere started to expand. It was as though the star was swelling up as seen from the Earth. Betelgeuse continued to swell at a constant rate of about 8 kN per second for most of the year. It wasn't until mid-November 2019 that the outward velocity decreased. Assuming this velocity, astronomers believed that the ejected material would have reached a distance of about 10 to 20% of the star's radius above the surface in the next 6 months. The outflow stopped by mid-November 2019, and astronomers retook optical images of the star. The researchers were surprised to notice 2 anomalies on Betelgeuse. First, the images revealed a dark southern hemisphere of the star. This created a dramatic contrast with the previous image obtained on the first day of the year. Second, there was a dip in the star's surface temperature, and it was found to have dropped by about 80 Kelvin. Astronomers used 2 independent methods to measure the temperature to be assured it dropped. One, they observed the infrared spectrum of Betelgeuse just 8 days after taking the new optical images. The spectrum confirmed a dip in the temperature of about 80 Kelvin. 2, they analyzed the intensity of the ratio of 2 spectral lines, vanadium-1 and iron-1. When this ratio increases, the phototropic temperature decreases, a trend that has also been observed in numerous other stars. During the Great Dimming, the ratio increased by a factor of 1.9, indicating a significant temperature drop on the star's surface. The brightness of the red giant reached an all-time low between January 27th and February 13th, 2020, about a year after the outflow began. The star started brightening again, reaching its standard magnitude after a few months. So, what happened to Betelgeuse? The researchers note in their papers that this pattern of variation and atmospheric response suggests that an ejection event originated in the photosphere and traveled through the extended atmosphere, eventually creating molecules and dust as cooler regions of the extended atmosphere were reached. A disturbed atmosphere, cooler and of lower density, remained. This is expected when the material is suddenly removed from the photosphere, allowing the remaining plasma to expand and cool off. Hence, all evidence suggests that Betelgeuse experienced a huge surface mass ejection, SME. Something similar to the SME happens on the Sun too, although it goes by a different name. This one is called coronal mass ejection, or CME. Solar corona mass ejections occur when there is an impulsive ejection of material, generally from the solar corona to the heliosphere. The dark spots on Betelgeuse's surface are thought to be many times larger than Earth's and cover up to 20% of the star's surface. The presence of star spots directly affects the brightness of a star, causing it to vary over time. This means the more star spots present on a star, the dimmer the star will be. This happens because the areas where the dark spots cover is much cooler, emitting less light than areas with weaker magnetic fields. This recent phenomenon with the Betelgeuse star has provided a learning curve for scientists. The observations provided by James Webb have given some insight into how red stars lose mass when they are about to die. Scientists have discovered that they lose mass or little bits of themselves because their nuclear fusion furnaces burn out before blowing up in a supernova. The amount of mass lost always has a significant effect on their fate. The recent loss of a massive chunk of its mass by the Betelgeuse star is most likely the beginning of the assurance that the loss of the giant red star is at hand. Scientists and astronomers are particularly concerned about it and are devoting their time to seeking a more definite answer to these questions. The massive ejection of mass matter by the Betelgeuse star is assumed to have been spurred by a convective plume over 1 million miles across, which bubbled up from deep inside the star. This plume bubble produced heavy pulses and shocks that caused a chunk of the star's photosphere to get blown away, leaving the star with a wide, cool surface area underneath the dust raised from the mass ejection. Supernovas can be incredibly beautiful. They can take up several shapes and colors, but this depends on the type of supernova and its environment. Despite their visual appeal, we must remember they are as dangerous as they are aesthetically pleasing. One of these supernovae's main dangers is the release of high-energy radiation upon explosion. These huge bursts of gamma rays can be thousands of times more powerful than the energy emitted by our sun. If these radiations hit the Earth, it can be deadly to life on Earth, as these gamma rays can damage the DNA of Terra life forms. Researchers are divided as to whether the Betelgeuse is about to go supernova on us. Some believe its time is almost done, while others believe the red giant still has tens of thousands of years in it. All in all, we cannot dismiss Neil's warning about Betelgeuse. If the red giant does explode now, we would have no way of knowing because we would be unable to see the light it emits for another 650 years. Do you agree with Neil? Do you believe that the massive supergiant has died and we are only waiting for proof of its death?